All right, Unit 1, Day 2. So it's still Worksheet 1, but the second half of Worksheet 1. Today is going to be about domains and the difference quotient. Domains and the difference quotient. Those aren't really related, but they're both easy enough to stick into one lesson. So first, domain. Do you remember what domain means?
X values.
Good, x values. So the x values that are either on the graph or that are allowed in the equation. It kind of depends on the situation as to how you want to phrase that. But it's definitely the x values that we're looking at. So the easiest ones, at least for most people, is the x values from pictures. That's the ones we like, because kind of like the vertical line test. Like you just look at it and get the answer. There's not really no work to do. But like vertical line test, you got to know what you're looking at. So let's say we've got some sort of sideways parabola type thing here. And we want to know the domain of that picture. I almost said function, but that's not a function. So the domain of that graph. You remember?
Negative infinity to 2.
Good. So in interval notation, the x values are covered from negative infinity to 2. Now, it's not quite the complete answer. What symbol goes with infinity? Parentheses. Always parentheses with infinity. And then a bracket on the 2. Remember, a bracket means equal to, or like include the 2. And the parentheses means don't include. That's a little bit weird for infinity, but I just remember it as you can't ever get to infinity. Infinity is not a number, it's more like a concept of way out there. So you can't get there, so you can't ever say you equal infinity. You're just headed to infinity. You do want to include 2 because it goes through 2. So negative infinity to 2. There's a goofy looking graph. So we read the domain, x values. I think about reading it left to right, and it's a little bit like the vertical line test. Like I think about scanning the graph from left to right. The first value happens way out there at negative infinity, and the graph continues to negative 1. Parentheses or brackets or one of each. What are we doing on this one? Parentheses on both, because we don't want to include negative 1. And then what's the symbol that means there's more stuff to write? The U. Good job. And then pick up again at 2 and go out to infinity. So you guys seem pretty good on that one. Pretty easy for domain from a picture. Just look at it left to right, think about the x values. Right, what's a little bit harder is from equations. So with equations, it's not so much about what x values you see as what x values are allowed, because some things don't work. So it's more about the allowed x values. And then that would show up on the graph, but the graph is sort of secondary to the equation. So there's two main problems that we will worry about. There's other problems, but they're in types of functions that we're not worried about yet. So for us, there's really only two things that we have to worry about. And the first one is square roots. Because what type of number can you not take the square root of? What type of number does not have a square root? A negative. So that's sort of the basis for what we'll do with square roots. You can't square root a negative. Well, I mean you can, but that's imaginary, and so that doesn't really work on the graph. So for us, for now, we can't square root a negative. So if the function is square root of 2x plus 6, well, that means that whatever's inside of there, you know what, let's add a minus 7 at the end. Mainly because the minus 7 at the end doesn't do anything. So we need to learn to look at what's under the square root, because that's all that matters. So 2x plus 6 can't be negative, but what's a more mathy way to say can't be negative? With the positive. Okay, but wait a minute. There's one number that's in between the negatives and the positive. 0. So can it be 0? Can we take the square root of 0? Yeah, 0 has a square root. So I want to include 0, but I need to be greater than 0. So it's whatever inside the house has to be greater than 0. So inside the house has to be greater than or equal to 0. There's sort of the overall strategy, theme, process for square roots. Whatever's inside the house has to be greater than or equal to 0. Outside the house, we're not concerned with it. Inside the house can't be negative, so greater than or equal to 0. And then solving an inequality. So move the 6 over, divide by 2. I still want my answer in interval notation. So some people will go straight from this answer to interval notation. Other people, me included, would almost rather see a number line. Because it's real easy to get from a number line to interval notation. So the number line is not required. Double check that one, make sure. Yeah. You don't have to draw a number line, so that doesn't have to be there. But it helps because then interval notation off a number line is just reading from left to right and saying we start at -3, we go to infinity, and we want to include -3. There's one thing that we didn't do in this example, or didn't come up in this example. I think you'd remember it, but what would happen if you had -2x is greater than or equal to 12? So it's like a little side note here. What would you do with that? Yeah, so when you divide by negative, you have to flip that inequality around as well. So you've seen that, but maybe it's been a while. So that would sort of mess up which way your domain was looking. So, all right. So square roots can't divide. You can't square root a negative. So whatever's under there, whatever's inside the house, greater than or equal to 0. The second sort of problem child for domain are fractions. Because just like you can't square root a negative, when we're fractions or dividing, what can't you divide by? What's that? 0. You can't divide by 0. So if there's a 0 in the bottom, that's a problem. In fact, a little review here. Maybe you've seen that thing. People struggle with this all the way through high school. If the 0's in top, what's 0 divided by 7, or 0 divided by 3, or 0 divided by 5? If the 0's in top, it's okay, it's 0. It's the 0 in the bottom that doesn't work. That's the no. So okay and no is maybe one way to remember the 0 rules. 0 in top, that's fine. 0 in the bottom, that doesn't work. Or you take it back to like a real world situation. If you have $0 and you want to divide that among your 5 friends, that's fine. Everybody gets $0. On the other hand, if you have $5 and you want to divide that among 0 friends, that doesn't really make sense. You still got the $5, but you're not allowed to divide it, so that doesn't even work. So undefined. 0 in the top, okay. 0 in the bottom is no. So let's look at an example. 3x plus 15 over x squared plus 7x plus 12. I guess we'll make it a function, so f of x equals all of that. And our job is to find the domain. Well, again, the only thing we're worried about is the denominator divided by 0. So I don't even care about the top. I'm just going to say the bottom can't be 0. So let's factor that. That looks like a reasonably easy one to factor. 3 and 4, both positive. Now, normally we would say x equals -3 and x equals -4, but it's kind of backwards this time because we don't want -3 or -4 because that would make it 0. So let's be careful. X can't be -3. X can't be -4. Again, we want the answer in interval notation. Some people can go straight from that answer to interval notation. Others of us, maybe it helps to see the number line. But be careful with, who's bigger, who's smaller. So can't be, so open circles at -4, -3, but it can be anything else. So now I want to write what I've shaded in interval notation. So -∞ to -4, -4 to -3, -3 to infinity. X can be almost anything, but it can't be -4 or -3 because that would make the bottom 0 and we can't divide by 0.
Why do you write the -4, -3 in parentheses? Why do you write that?
That's a good question. I was just going to say that this middle portion is the portion that's most forgotten. It's like people get the whole problem right and they just leave that out for some reason. It has to be there because that corresponds with this part of the picture. So you got to make sure you get all the pieces in there. Let's try to color code it there. So the purple, the green, the orange. You make sure you get all 3 pieces written down. Did that answer your question? So it's a good question, and I did have it highlighted to make sure. For some reason, people will omit. They set up the problem right, so they know the theory, they know how to factor, they get here, and then they leave out the middle part for some reason. So square roots, you can't square root a negative. Fractions, you can't divide by 0. So the good news is you already know both of those things, so you're not, in some ways it's not that new. The last type, I said there was only 2 types that have problems, but we give you polynomial problems. The issue is they're not even problems. Like they're not difficult. I'm not saying that very well. Let's find the domain of x squared minus 7x plus 6. The trick is some people like jump into this problem and start factoring, but think big picture. Domain means what am I allowed to plug in for x? So look at that picture, or look at that equation. Is there anything that would be a problem plugging in? Any type of number that would be a problem here? It's kind of a trick question, because there's nothing that would be a problem. Like everything's okay. And there's no square roots, there's no fractions. So the answer is all real numbers. So negative infinity to infinity if you want to stick with the interval notation. If you just want to put the script fancy R thing, which means all real numbers, that's okay as well. So this is the easiest question, but if I bury it in the midst of fraction questions and square root questions, somebody's going to miss it because they do something with it when you don't even have to do anything with it. X can be anything you want, so there's really nothing to do with the problem other than be careful and don't do something with it that's not called for. All right, so that's domain. Domain from a picture, pretty easy. You're just looking left to right. Domain from equation, only 2 issues. Square roots can't be negative. Fractions can't be 0. Anything else is fine for us, for now. Second big topic of the day, and again, these aren't, usually if there's 2 Roman numerals, they're like related to each other. They're not today. The difference quotient. All right, what's difference mean? What's that the fancy word for? Difference. It's not division, subtraction. So difference means subtract. And quotient, what's that the fancy word for? Divide, or division. So it sounds fancy when you say difference quotient, but really all it is a subtraction problem followed by a divide problem. So here is the difference quotient. F of x plus h minus f of x all over h. That is the difference quotient. We will give you that. It's hard enough to deal with the algebra for it, so you don't have to memorize that formula until you get to calculus next year. But for us, we will give you that. I will say something like, use the difference quotient or find the difference quotient given that f of x equals whatever, and then I'll say, here's the difference quotient. So you don't have to memorize that. Got to know how to use it, how to simplify, how to do all the algebra, but you don't need to have that memorized. Let's find the difference quotient if f of x equals x squared. Kind of pause for a second. Big picture, this is the only new thing in this section, is this formula, but we're going to give you the formula. The rest of it is algebra that in theory you know how to do. So the rest is just, how are your algebra skills? Because I need to find basically all 3 of those pieces and then we'll put them together. Now the good news, I gave you one of the pieces, f of x. H is just the letter h, so we're good there. So the big thing is to find f of x plus h. And you might remember we did that a couple times yesterday, so this isn't completely new. We've done that a little bit. So f of x plus h means I need to square x plus h. Right? Because whatever's in parentheses is the input to the other side. So squaring x plus h. Hopefully you can do that quickly and easily, maybe even without writing it all out. But show as much work as you need to show to make sure you get the problem right. X squared plus 2hx plus h squared. Okay, so I sort of keeping my finger or my brain on that big overall formula. Now I know f of x plus h, so let's plug that in. So x squared plus 2hx plus h squared minus f of x, which is x squared, all over h. So by far the hardest part is finding f of x plus h, because f of x is given, h is just a letter. So the big deal part of the problem is, can you find f of x plus h and then handle all the simplifying. So let's see, the x squareds will go away, and it's the only thing that goes away. 2hx plus h squared all over h. Anybody see what else we can do with that? Cancel out an h from everybody. So most, maybe not most, some of you will get the correct answer from there. Others of you will want to more show the work, so factor out an h. It's certainly easier to see what cancels if you factor it out, but you don't have to show that step. So again, that second to last step, helpful for some, unnecessary for others. Leave it up to you. So there's the answer we're looking for. That's the difference quotient, 2x plus h. Why we do this, that has a lot of meaning in calculus. Doesn't have much meaning in pre-cal, but we got to make sure we got all the algebra down before we get to calculus. Let's do one more difference quotient. Yeah, I mean, we'll still have 20 minutes to work on the worksheet. Find the difference quotient if f of x equals 3x squared plus 2x. Oh, I hear some of you turning the page. And if you're at the bottom, you might want to go ahead and turn the page, because this is going to take a few lines, because you got to find f of x plus h, then you got to put it all together, then you got to see what subtracts and what cancels. So there's a lot going on these problems. So job one is to find f of x plus h. So I'm going to press pause and you try and see. You simplify f of x plus h. I suppose you could keep going if you like, but I'm going to jump back in a minute to show what f of x plus h is. Okay, so there's f of x plus h. Didn't show a whole lot of work there, but I feel like I've foiled x plus h enough times that I know what that is. I could also look up that previous problem and see it. And then distributed 3 to everybody. Distribute the 2 to everybody. So it's like I'm sort of a third of the way through the problem now. That's the f of x plus h. So f of x plus h is this massive thing minus f of x 3x squared plus 2x all over h. It's like more of an accounting problem than anything. I just keep up with all the stuff, minus signs, distribute. Just be careful. Let's see, the 3x squared and the 3x squared will cancel. What about the 2x and the 2x? Do those cancel? Yes.
Because there's a minus sign in front of it.
Yeah, there's a minus sign out there, so that's really a minus 2x. I just didn't want to take the time to rewrite this whole thing only to distribute a minus sign. 2x minus 2x will make the 2x's go away. Now, some of you will try to be super efficient and write the final answer from there, and some of you will be correct, and some of you will mess it up. So I'm going to take the time to rewrite. You don't want to do too much on one line or you get confused. So I'm going to rewrite what I've got, even though I know what the next step is, and maybe could do it without rewriting that, but just want to be careful here. All right, last time I factored out the h. This time I'm feeling adventurous, and I'll not factor it out. I can see that the h will divide into everybody. So 6x plus 3h. Be careful, because the h squared, one of them cancels. And then plus 2. And so there's my difference quotient. So I say the only thing new today is the difference quotient. We give you what it is. Your job is to be super careful with the algebra from there on. All right, the assignment is worksheet 1, 16 to 33, and double check to make sure that goes all the way. It's the rest of worksheet 1 is the easier way to say it. Yeah, 16 to 33. So a little bit of domain problems and 5 difference quotients. Answers are posted in Schoology, so you could check your work there.